Hello, welcome to another video for Eng204 Engineering Design. And today in 3D modeling using Creo, we learned two new operations. Previously, we've learned extrude and revolve. Both of those operations allow us to make 3D objects. And today we'll learn sweep and later helical sweep. So technically speaking, all four of these operations are different types of sweeps. By sweep, I mean an operation where you first make a cross section. So for example, if you imagine that this circle is a 2D cross section, it's a 2D sketch, and then you sweep it in the perpendicular direction along this normal, then you'll get a cylinder. And since this sweep is being performed perpendicularly, we call it extrude. If instead of sweeping it perpendicularly, we sweep it along a circular profile about a center line, then that's known as revolve. What if you don't want to sweep it perpendicularly or about an axis of rotation? What if you want it to traverse a convoluted non-standard profile? For that, we'll use the operation of sweep. And if you want it to traverse a helical profile along a helix, then that sweeping operation is known as a helical sweep. So let's start with sweep. In this sheet that I'll be providing along with the video, I've listed the two main requirements that you have for sweeping operations, and they're similar for all four operations, in fact. Number one, you need to provide a cross section, so the profile, which is the cross section, and then you have to provide a trajectory, the path along which that 2D cross section would be swept. Let's start a new project. I'll call it sweep. I don't really care about the dimensions. And the steps, the general steps that we have to follow are listed over here. The first step is that you have to make the trajectory, which is the profile that your cross section will follow. You make a sketch, or if you want, it could be a curve as well, but in most cases, all we need is a sketch. So I'll select this plane and I'll make a sketch. So this would be the path along which my cross section would be swept. I'll use the spline tool to make an irregular path. So what I want is some cross section, which I still have to define, to be swept along this path, starting at this end and ending at this end. I'm happy with this. Click OK, and I'll call this my trajectory. Next, we will start our sweep operation. And this within the model tab is where you can find sweep. If you click on this drop down menu, over here you'll find different types of sweeps, and one of these types, helical sweep, is one that we'll be looking at shortly. But for now, let's just select sweep. The first thing that you need to provide it is the trajectory. So it's asking for a trajectory. Select items. After I've chosen this command, I'll select the sketch that I made, which would now be my trajectory. Okay, I think it's struggling to select it from the model tree. Hopefully it will be able to select it from the graphical interface. So I've selected that trajectory, and now I need to tell it where to start the sweep from, because it can start the sweep from this end or this end. In most cases, it doesn't matter, and I'll explain why it can matter in some cases. But since we originally wanted the sweep to start from this end, I'll click this purple arrow, and that will reverse the ends, and now my sweeping operation would start from this end instead of starting from this end. So we've selected the trajectory, we've chosen the starting point, and now we'll tell Creo what our cross-sectional profile is going to be. And for that, within the sweep tab. So when we started our sweep operation, a new tab sweep opened up. We will select the sketch command. And now Creo is expecting you to sketch the cross section that you want to be swept. If we move things around, you can see that there are crosshairs which are formed at this point, which is our starting point. Whatever cross section we make over here would be swept along this trajectory. So when we are looking at it perpendicularly, that's what Creo does for us automatically. These crosshairs mark the starting point of our swept profile, which in this case is in a 2D standard plane, but it doesn't have to be in the standard 2D plane. It can actually be in multiple planes as well. If you used the curve command, you could have made a 3D curve. So, but there would be a perpendicular plane at the starting point of each curve where you will have to make your cross section, and Creo automatically takes you to that perpendicular plane. That's what you see over here. And these crosshairs tell you where the start of your trajectory is. For now, I'll just make a simple circle. I'm happy with this sketch. And now automatically you can see that this cross section which I made along this plane, which is shown by these two intersecting center lines, has been swept along the line, the trajectory that I made. And in this way, you can perform a sweeping operation. And if you want to make unconventional profiles, which are not perpendicular to a cross section or which are not actually symmetric, you can use the sweeping command. You couldn't have made, or you couldn't have easily made something like this using extrude or revolve. I would argue you can't make these using extrude or revolve. That's how you perform the sweep operation. A few other things that you can look at. So going back to sweep again, this is where we're starting from. If you don't want to sweep the entire length of the trajectory, you could move this handle, this yellow handle, and stop it to the point where you want things to be swept. Sometimes you might have a longer curve than you want the 3D object to be. So you could truncate the sweeping operation earlier by moving this handle as you want. And another feature within the sweep tab is this thicken sketch feature. If you click this, you will see that your part, which was previously a solid, has now been hollowed. Let's say that you wanted to make a hollow channel of a non-standard profile. You could have made two circles and annulus in your initial sketch and then swept it, and that would have made something similar. Or you can make a solid, select this option from here, which is add thickness, so that automatically creates for you a hollow profile, and then you can prescribe how thick you want your part to be at every point. And over here, this is slightly different from just initially using a hollow 2D cross section. So let's say that I want this tube that I'm making to have a constant thickness of 6 mm or 6 inches, I think, in this case. I'll enter that thickness value over here, and in this way, I've created a hollow channel using the sweeping operation. So that's everything about the sweeping operation. Play around with this. It's not very difficult once you've gotten comfortable with the basic commands of Creo. So now let's see how we can perform a helical sweep. Helical sweep is different from regular sweep, that the profile that you prescribe isn't uh, an arbitrary profile. It is a profile along a helix. So I'll delete these entities that I created just because I don't want to create a new part. And for helical sweep, the general steps that we'll follow are listed over here. The first thing that you need to prescribe is the profile of the helix. And profile over here is used a bit non-intuitively, where the profile of the helix defines the length from the starting uh, point of your helical feature. It could be a spring, it could be the threads on a bolt, to the ending point where you want that helical feature to end. This is not the 2D cross section. This is just a line which marks the starting and the ending point of your helical feature. Once you've defined that, then you will define the axis of your helix, so the central axis about which your helical feature would be uh, swept. And thirdly, you will sketch the cross section of the profile that you want to be swept along that helical profile, starting from the base point of your helix profile line that you made to the end point of the helix profile line that you made. And then you will fix parameters of the helix, like the pitch and its handedness. So let's try to implement this, and hopefully it will make more sense. So the first thing that you need to do is make a profile, and that is nothing more than a line in a sketch. So I'll make a line over here. I'll call this my profile. The next thing that we need, as listed over here, is the axis or rotation of the helix. You could do this in two ways. You could either use different axes, which might already be a part of your design. For example, if you have a cylindrical feature already, that would have an axis. If not, you could always add axes from this datum menu over here. For example, if you wanted to add an axis at the intersection of these two planes, you will select these two planes while holding down control, and you will be able to make a new axis. But to keep things simple, at this point we won't use this option. What we'll use is the center line option, which is an option within Sketch. So I'll go back to my profile, and I'll define the center of my helical profile, the axis of my helical profile, using a center line. Let's say that I want it to be over here. I'll hide this axis that I created so that it doesn't cause any confusion. So what will happen now is that once I've prescribed the cross section that I want to be swept along a helix, that would start from here. It would form a helix around that center line. I can't see the center line over here right now because I'm not in sketch view, but it's somewhere over here. It would coil around that center line and form a helical feature. Let's see how we can do that. Instead of sweep, we'll select helical sweep. The first thing that we need to provide is the profile of the helix. We'll select this sketch from here. Similar to simple sweep, we can change where we want our sweeping operation to start from. I'm happy with this. And the next thing that we need to provide is the axis of the helix. Since there already is a center line internal to the sketch, Creo automatically chose this option of internal center line. If you make a sketch with the profile and a center line, automatically that center line would be chosen as the axis of your helix. You could do that, or alternatively, if you did not have a center line, even if you did, you could ask Creo to ignore it and manually select an axis at this point. So if I did not want to use the center line, I wouldn't have made that center line. And at this stage, where Creo would ask me to provide the axis of the helix, I would have selected this axis which I made. But for now, this is good. So we have the profile, we have the axis of rotation, and now we have to give it the cross section that we want to sketch. Similar to sweep, within the helical sweep tab, we will make that cross section by selecting sketch under the section command, which would be the center of our axis, and depending on where you want your helix, the outside of your helix to be, you can make that cross section. I want my helical feature to be along this profile that I made. So, and I want the cross section to be, for now, just a circle. So I'll make a circle over here, give it some diameter, and then if I did everything right, this circle should be swept along about this center line up to this point, and that's what happens. You did not have to make that circle over here. You could have made that over here as well, and that would have swept it about the same center line and would have made a bigger uh, uh, spring, compression spring in this case. Uh, as with any helical feature, you need to prescribe the pitch. Right now, the pitch has been selected to be 15.9. You could play around with this. If I increase the pitch to 25, the number of coils that I have decreases. If I reduce the pitch to 5, I have what looks like an extension spring. So this is how you can adjust the pitch of your helix, and by default the handedness of your helix would be right, but if you want a left-handed helix you could change that from here. So this is how you can how you can perform a helical sweeping operation, and in the next video we'll use helical sweep along with extrude and revolve to make a bolt. Well, thank you for watching this video.